There are 2 trillion galaxies in the observable universe, each containing hundreds of billions of stars, and yet despite all of this, we're supposed to believe that life only happened once on this tiny blue speck in the middle of an endless sea? Well, here's the math that says otherwise. In 1961, a physicist sat down and did something nobody had ever done before. He tried to calculate how many intelligent civilizations exist in our galaxy right now. Not guess, not theorize, actually calculate. His name was Frank Drake, and what he found should have changed everything. The Drake equation. It looks intimidating, but it's actually just multiplication. You're taking a series of fractions and multiplying them together to get to one number. Here's how it goes. The estimated number of technologically advanced civilizations in the Milky Way right now equals how many new stars form in our galaxy per year times what fraction of those have planets times of those planets how many are in the habitable zone, meaning not too hot and not too cold either, and then times of those planets how many actually develop life. Then times how many of those that develop life that is intelligent, times how many of those that have intelligent life build technology that we could detect from space. And then lastly, times the lifespan that such a civilization survives on average. And here's the thing, even with the most conservative estimates, plugging in the smallest reasonable numbers for every single variable, you still end up with the result in the hundreds of intelligent civilizations in our galaxy alone. Use optimistic numbers, and now you're looking at millions. So the math is pretty clear. We shouldn't be alone, and that's where it gets weird. The Fermi Paradox. In 1950, physicist Enrico Fermi was having lunch with his colleagues when he asked a simple question that nobody could answer. If intelligent life is so mathematically likely, then where the hell is everybody? I mean, think about it. The universe is 13.8 billion years old. Our galaxy alone is 100,000 light years across. Even at a fraction of the speed of light, a sufficiently advanced civilization could have colonized the entire Milky Way in just a few million years. That sounds like a long time, but on a cosmic scale, it's nothing. It's like 2 minutes in a 24-hour day. And yet, silence? No signals, no visitors, no evidence of anyone else out there. The Drake equation says they should exist. The universe, however, says we can't find them. That contradiction is called the Fermi Paradox, and nobody has solved it. There are a few proposed explanations of the Fermi Paradox, and each one is more unsettling than the last. First, the rare Earth hypothesis. Maybe intelligent life is just incredibly rare. Maybe we got incredibly lucky. Maybe the conditions for life are so specific that even with 2 trillion galaxies, it almost never happens. This is called the rare Earth hypothesis. Second, the zoo hypothesis. Maybe they do exist, but they're not talking. Maybe advanced civilizations go silent by choice. Maybe they're watching us but decided not to make contact, just like how we watch bacteria without it ever knowing of our existence. This is called the zoo hypothesis. We're basically animals in a cosmic zoo, and they're observing without interfering. Third, the great filter. And this is the one that should scare you. Maybe something, someone kills every civilization before it gets advanced enough to reach us. Something that every intelligent species eventually hits. A wall, a filter, a mysterious point of death. And maybe we just haven't reached it yet. The Mediocrity Principle. This is the pure probability argument. The core idea behind it is that there is nothing special about Earth. Our sun is an average star, it sits in an average part of an average galaxy. Earth is an average-sized rocky planet at an average distance from its star. Nothing about us is remarkable on a cosmic scale. So if life happened here on this completely unremarkable rock we call home, the math says it should have happened elsewhere too. Billions of elsewheres actually. The probability that out of 400 billion stars in our galaxy and 2 trillion galaxies in the observable universe, life only sparked once is so small it's almost mathematically indefensible. It's laughable. It'd be like buying a lottery ticket, winning, and then being told you're the only person who has ever won a lottery ticket in all of human history. It's possible, but I mean, come on. The great filter. So here's where we land. The math says we shouldn't be alone, that there should be others out there. The silence, however, says that we are alone. And the most terrifying explanation for this contradiction is the great filter, the idea that we're living on a ticking time bomb, that somewhere between dead matter and a galaxy-spanning civilization, there is a step so difficult, so unlikely, that almost nothing makes it through. A filter. And the question that should keep you up at night is, have we passed it? Or is that step still ahead of us? If the filter is behind us, if it was something like the jump from single cell to complex life, then we got lucky. We've made it through already. And maybe we really are one of the few. But if the filter is ahead of us, if it's AI, if it's nuclear war, if it's climate collapse, or if it's something that we can't even imagine yet, then every civilization that came before us hit that wall and went silent. The math says we're not alone, but the silence might mean everyone else has already lost.